Don't make me get up.
1 per second.
Yeah.
I can feed myself.
Yeah. But he don't want.
What?
So he will take mine. And Yusuf also will take some.
Dog. Oh yes. He doesn't want. Better.
You guys are weird.
No.
You haven't given us Steven.
No, we found it.
I got some.
Oh, thank you. It's mine.
Right, we'll have a look at the homework, and then that finishes electricity, and we don't have any waves homework to do. So actually we're doing pretty well for time. How many more physics classes do we have this week? One more double class? No. A double and a single, is it? Perfect. We'll get 2 more waves done. If we get 2 more waves done this week.
We have a double tomorrow, and that's it.
No single?
Tomorrow, Thursday, and Friday we don't have physics.
Why don't you have physics on Friday?
We have it on Friday.
You have 1 hour at like 2 o'clock.
Yeah, she told me something now.
A double and a single.
Yeah, as you were saying. Yeah.
Hashtag class.
When you tell me
Yeah.
what I'm trying to tell you.
Indeed. Okay, let's have a look here. So we were talking about this one a little bit last time, Yusuf. We were talking about how to solve the second part. So the first part is how much resistance is in the wire. And that's pretty straightforward because we just use the formula rho L over A, which is rho L over pi r squared. What is the rho? 1.68 times 10 to the minus 8, and the length is 1 meter. Yeah, and then the radius is 73 micro. So 73 times 10 to the minus 6 squared, which equals 1 ohm in the end. So nothing a problem there, right?
I didn't know how to convert.
Which convert?
Yeah.
The minus 6?
Yeah, it's minus 6.
Because micro is minus 6, yeah. Yeah, so this symbol here means micro, minus 6. Okay, part 2 is this where the wire gets cut now, is it?
Yes.
It's cut into 2 to make 2 resistors. How much resistance is in each? So, you know...
And how?
No, not necessarily in half. So it's cut into 2 pieces. We do know that the resistance in the first one plus the resistance in the second one should still add up to 1. So that's how much you have. And you also have the formula that I gave you. V out equals R2, isn't it? Over R1 plus R2 times V in. Now what's great here is R1 plus R2 is 1, so this is gone. So you get R2 equals 22 over 220, which is 0.1 ohms, which means R1 should be 0.9 ohms. Did you get that, Yusuf?
I used a different method and I got the same answer.
Was it easier method?
No. But like...
No. You can stop talking now. Did you get this one? Yeah. Swan, did you get this answer? What did you get?
Now that I know this method, I'll start using
Huh? What? It sounds like you made a sign mistake or something.
1.2 and 1.8. Close to the answer, she rounded off somewhere.
No, that's quite wrong, because the total should only be 1 ohm.
Yeah, it is wrong. 1.8 and 1.2. That is wrong.
So that's the double.
Yeah, 1.8 and 1.2.
0.8?
No, she said...
1.8.
Yeah, 0.8 and 0.2.
Okay, well then that's not too bad. Right, part 3.
Would you like to learn it off?
Please.
Oh,
Do you
how long?
remember something now?
Yeah. Part 3. How long is each resistor? So, if you just rearrange this formula at the beginning, you can get L equals RA over rho. Yes? So, for example, L1 would be R1 A1 over rho, which would be R1 pi R squared over rho. Now, do we know R1?
Yeah.
Yeah, we do. It's 0.9.
Yeah, no.
Do we know pi? Of course. Do we know the radius? Yes.
Yeah.
We had it earlier.
That's the diameter.
Yeah. And do we know the resistivity?
Yes.
We do. So if you just put those numbers in, you will get 0.9 meters here for the length. Likewise, for L2, you can repeat, and you will get 0.1 meters for that length. Okay.
I have a question.
I didn't bother writing this down because we know all the numbers here, so we can just put it in on our calculator. Yes.
When I was doing this, I thought, are those the only two possible answers? Because in the part 2,
No, there's no second answer here. It has to be R1 is 0.9 and R2 is 0.1. It has to be. There's no symmetry here. No, there's no second possible answer.
If it's 0.9, shouldn't it, the resistance be higher?
Okay? Yeah. Alright. Part 4 now. A 10 ohm resistor is connected in parallel to the output. What is the voltage through the large resistor? You may use Kirchhoff, although there's other ways to do it if you want. So the picture we have right now is there's a resistor here, R1. What do we say R1 was? 0.9. Then there's a resistor here, 0.1. And there's a voltage here of 220 volts. And there's another resistor here now of 10. And we would like to know what the voltage is here. And we could use Kirchhoff like I suggested, or you could use my the rule I gave you for the potential divider. But if you do use the potential divider rule, what will you need to do first before you can use the rule? The new OR, yeah. So we have 1 over OR equals 1 over 0.1 plus 1 over 10. So 1 over OR, that equals
100 over 9.
this is 10 plus 1 over 10, isn't it? It's like this.
Yeah.
101 over 10.
Yeah, 10.1.
For the final answer. 10.1 is, yeah, or is 10.1 ohms. This is the new R2. So, V out, which is what I want, is R2 over R1 plus R2 times V in. That's 10.1 over 11 times 220.
Is it 10.1 or?
Isn't it? Isn't it R2? Oh no, sorry, it's R1 on the top, isn't it? I forget, what's in the formula?
The R, the total resistance.
One.
Hang on, one at a time. Is it R1 or R2 on the top in the formula? Are you sure? Okay. And what do you think is the problem here, Yahi? No, is this okay? No, something does feel wrong here now.
The new output is not 10.1.
Yeah.
No, what is it? It's
0.01.
0.09.
0.099.
oh, I forgot to flip it, didn't I?
Yeah.
Amateur mistake. So R2 is 10 over 101, which is 0.099. Okay, so now V out is 0.099 over 0.9 plus 0.099 times 220. And what will that equal, please? Well, I'll type it here then. 22.25? Sounds believable. Let's check.
Did you use 0.9 or 0.8?
99 or 9?
9.
21.8. Okay, next. Why is the voltage not 22? Well, because the resistance is different, but it's nearly 22. So then the last part here, change the length so that it will be 22, exact. So adjust the length to make it exactly 22. That's going to be a bit tricky. It shouldn't have to change too much, just change a little bit. Okay, so let's scroll down a bit.
Increase to one of the lengths, or does it have to stay one? And you're changing the ratio of the...
Oh, the way I was picturing it was they still total to 1. You have to use the full length. Because what happens, this is actually a real circuit, I forget what it's called, it's a potential divider, but it's a special one where you use a wire. And I said in the question you cut the wire to make 2 resistors, but what happens in real life is you slide across the wire to change the length. So, yeah, I was picturing using the full length of the wire. Okay, so let's have a look here. So we want to find L1 and L2. Well, first we should find maybe R1 and R2. We still need R1 plus R2 to equal 1. That hasn't changed. But what's different now is we need the output to be 22. So 22 needs to equal R2 over R1 plus R2 times 220. Now, R1 plus R2, we still need that to be 1, so that's gone. So we need R2 to equal 22 over 220 equals 0.1. But what is R2? It's made up of 2 resistors. 1 over R2 equals 1 over the resistor which we don't know what it is. Oh, you know what? Sorry, hang on. No, I made a mistake here. Well, not a mistake, but I need to be careful with my letters. I need R2 to be 0.1, but I need a different letter. Let me just do this again, but I need to put different letters down so not to confuse me. Right, this one we'll call R1, this one we'll call R2, and this one here we'll call 10. Yes, is that okay? Now, in the formula, yes, R1 plus R2, that should equal 1. But in the formula for V out, 22 equals times 220. This is R1, and it's not really R2. What goes here in this example? Yeah, well, it's this total. So I'll just call that R by itself. And what goes on the top here? R, yeah. So this is our second formula. So we have 3 variables here, R1, R2, and R. But I kind of know how to get R here because I can use this formula. 1 over R equals 1 over 10 plus 1 over R2. So our job is to put the 3 of these together some way to get an answer. Sounds easy, but it's not. So we need to decide what way to put things together. Well,
substitute the first
which one you think?
Rearrange this one to make it...
Wait, hang on, let's put in some numbers. 1, 2, 3, right, what do you reckon?
Rearrange 1.
To get what?
To get R2 equals...
R2 equals, yeah, and then?
1 minus R1.
Yeah, no, I know that, yeah. But then what do you do with this?
Oh, we put it in 3.
Put that in here.
Yes.
And this gives us R and R1.
Yes, and then we use simultaneous for 2 and 3.
Go for it, Yusuf.
Yeah.
The end it's the 3 numbers first.
I don't think there is any really easy way. And the only thing I could think of maybe is here in number 2, you could rewrite that as 22 over 220 is 1 over 10. So you could say 1 over 10 equals R over R1 plus R.
Now stop. Wait a minute. You can use, you rearrange the third one,
Yeah.
and then make it 1 over 10 equals to
It's how-
R, 1 over R minus 1 over R2, then this equals...
Okay, so you can say 1 over 10 equals 1 over R minus 1 over R2.
And then 1 over R...
And then
minus
these
1.
we can make equal. R over R1 plus R equals 1 over R minus 1 over R2. So now we need to put this one together with this one somehow.
You still have to rearrange one to get one of them alone, and you substitute it.
No, I don't think...
I think my way was better.
10 is 10 R, like they are not the same value. That's not good.
Now hang on, Lee's talking, which means something good is coming up. Go ahead, Lee.
Yeah, I think you can simplify the 3 easier.
Simplify 3, yeah.
Yeah.
To get R or R2?
R.
Right, let's see. So we can get 1 over R equals, and this is 10 R2, R2 plus 10. So R equals 10 R2 over R2 plus 10.
Is this what you meant?
Yes.
And then what do I do with this?
And use.
You say, that's right. I'm telling you, it
Easy
will work.
to do.
Yeah, but then what do I do next? Tell me what to do next. What to do next, right, so?
Rearrange R1, equation 1.
Yeah? To get what?
To get
R2?
Yes.
R2 equals 1 minus R1
And then put R2's value and
into this one.
into the third one, yeah.
This one that I just have here, yeah? So now you have R equals 10, 1 minus R1 over 1 minus R1 plus 10. So you get R equals 10 minus 10 R1 over 11 minus R1. Now what?
Now you have R and R1 from
This one?
This one and the second equation. There are only 2 unknowns use simultaneous. But if you didn't arrange the third equation, and just went to the third thingy, it would have been easier, but you can do it still.
Yeah.
Simplify that one.
This one?
Behind.
This one?
Yes.
Yeah?
Divided by 1 minus.
Yeah, and you can also do that
1
to
minus R1.
to
I don't
cancel
think you
the
can.
Yeah, like.
1 minus R1.
Okay, these are all great ideas. Now I'm actually going to do it, okay? I'm glad we were all thinking about it. But it doesn't really matter which way you do it, because there is no quick and easy way to do it. But I do think it is good to think about strategies here. So what I'd like to do is write down what's in each equation. So in the first equation we have R1 and R2. In the second equation we have R and R1 in the second one here. And in the third equation we have R and R2. Now in this one here, is there any variable that's in all of them? No. So we're going to have to eliminate a variable from 2 of them and from 2 of them. So for example, we could eliminate R1 here, and we could eliminate R here. So you could just be left with R and R2, and then here you would like to...
R and R2. And then
No, you have R1 and R2, which is kind of a bit bad. We don't want that. So maybe we should rewrite them in a different order. Please. 1, 3, 2. R1, R2, R2, R1. Yes. So here we could eliminate R2 and be left with R1. And here, but then you're left with R1 and R2, which is not great, you know.
What if you just don't eliminate anything? No. Like, what if you didn't do any, like, get the R, and instead of that, like, write R2 plus 1 over 10, and then you'd have R1, R2, and all the equations. Isn't that
Good.
easier? Because, like, then
Right.
there was...
I think I'm thinking about deleting this one. I was going to delete it last year, but I forgot to. I remember, oh yeah, this was hard last year when I did it. So, this is too difficult for the exam. But
don't stop now, please finish it.
yeah, no, don't stop now. No. R1 plus R2 equals 1. I'm happy with that. This one we should simplify it. So we have 1 over R equals 10 R2, yes? R2 plus 10. So if I cross multiply, I get 10 R2 equals R2 plus 10 R.
So why the R? Why don't you just write R2 plus 1 over 10?
R2 plus 1 over 10?
No, instead of R.
Yeah?
R2 plus 1 over 10.
What's true?
What?
Because R is R2 and the parallel resistor.
Yeah?
So it's R2 plus 1 over 10.
Yeah, give R an equation.
No. It is 1 over R2 plus
Yeah, it's
1 over 10.
Yeah.
Okay, so why don't you do that?
Yeah, do that.
Do what?
Write the equation of R.
Yeah.
Well, it's
Just
already
1
written.
over R2.
Equation
No,
3.
like instead of that, he'll add another value, and it would be R2. So like it would
Make an
only have
equation for R2.
no. Like just okay. So 1 over R2.
Yeah?
1. Okay. Now.
Now use your words. 1 over R2, yeah?
No,
Plus
Yeah.
1 over 10.
Yes.
That equals R.
No.
No.
That equals 1 over R.
Equals 1 over
1
R.
over R.
That is equation 3.
Yeah.
So can't we do that?
No. Yeah, well, I'm actually deleting the question. But I feel like now we've committed too much to it that we have to see it done. Okay. One sip of coffee, please, and then we'll start it.
Please continue.
Make that
Please.
two steps.
I am continuing.
Yeah.
Patience. All right. Yes.
What happens if one thing by one thing? Like, for example, 1 over 2 multiply 2 over 3. How can you do that?
Multiply the top and multiply the bottom.
Yeah, plus multiply them.
Wow. Okay. I don't want to do it Faisal's way because he calls it Faisal's way.
Doing it. You do it in another way, then we'll see if we get the same answer.
Yes, okay. Fair enough.
Based on
Right, I'll put this one into this one here, so I get 22 equals R over, and here we can say R2 equals 1 minus, R1 equals 1 minus R2, so that's R over 1 minus R2 plus R times 220, so 1 over 10 equals R over, that doesn't really simplify, 1 minus R2 plus R. So this equation has R and R2 in it. This equation has R and R2 in it. So I should be able to put these together. Now the question is, do I replace the R or the R2? Well, R is in it twice, but R2 is only in it once. So it would make more sense to only replace the R2. So I can say 1 over R2 is 1 over R minus 1 over 10. So R2 is 10R, 10 minus R. So R2 is 10R over 10 minus R. So I can put that in there. I get 1 over 10 equals R over 1 plus R minus R2, which is 10R over 10 minus R. Now that needs a good bit of cleaning up. 1 over 10 equals R over, and then here we can put these together as 10 minus R. So that is 1 plus R. If I think of this as over 1 plus R times 10 minus R minus 10R. So I get 1 over R equals R times 10 minus R over 1 plus R over 10 minus R minus 10R. So at least there's only or unknown in this. Cross multiplying, I get 1 plus or times 10 minus or minus 10 or equals or by 10 minus or. So expanding, I get 10 minus or plus 10 or minus or squared minus 10 or equals 10 or squared minus or cubed. So simplifying here, what do I get? I get, take everything to the left, or cubed. Minus 10 or squared minus or squared is minus 11 or squared. 10 or minus or is 9 or, minus 10 or is minus or. Plus 10 equals 0. Great. So now I just have to solve a cubic. I don't even know if this cubic will have at least one answer, but I don't even know if it's a nice answer. Let's try something simple like or equals 1.
Isn't it minus 9 or?
Is it? 10 or minus or is 9 or.
Oh, there's
Something minus some.
Oh, actually, this cancels this. Yeah, so you're left with minus or. 1 minus, so what was this? 11?
Yeah, minus 11.
1 minus 11 minus 1 plus 10. What's that? Not 0, is it? Minus 1. 1 minus 1. No, it's not. Let me try minus 1, you suggest, is it? Minus 1 minus 11 plus 1 plus 10. Is that 0? No. Let's check with the calculator. Mode 54. 1 minus 11 minus 1, 10. Yeah, we have no way of getting it. It's going to be a messy answer. So this question now is too difficult for you to solve because we do not have any method until semester 2 to solve cubics that have ugly answers.
I have a quadratic.
Good for you. I'll get you the quadratic well done badge. Actually, I'll put it on the screen for you. It'll be a star, and we'll put a quadratic inside of it. We'll go on to the next part now. So, yeah.
Can we have minus?
No.
Okay, could you just do one thing? Like just
No, this question is being deleted. I made it way too hard, even for me.
No, just like for me, like for further.
Yeah, what?
1 over r equals to 1 over r2
I thought we talked about this, yeah? Plus,
plus 1 over 10.
yeah.
How can we make it equal to r?
Yeah, so you would have to put these together.
How can we flip them? Can we flip?
We can't. We have to put these together as one fraction first. Then we can flip them. This is what you're looking for. Yeah? Yeah. Yes?
In the example, I use the different signs to represent the.
That's fine. Yeah.
That's fine.
Yeah. This question, part 6, is way too difficult for the exam. Way too difficult for the exam. And I know I say this every year and I forget every year. I need to delete this question from the homework. It's way too difficult. Let's have a look at the B now. So the B, I give you the new length, and I want to know what is the output voltage now. So we need to calculate the new resistance. So the formula is R equals rho L over A. Did anyone calculate it for the new L's? Oh, it's going to be 0.1009 ohms, and R2 will work out to be, using this formula, 0.8991. In part 2, what is the power? Okay, so now a different formula is needed. What formula could we use for power? IV. But we don't know the I. So if we use our triangle, VIR, we could replace the I with V over R. So this would be V squared over R, which is good because we know the V and the R. What is the R here? It is 0.8991. And did we work out the voltage? No, we didn't. That was part 1. Oh, I didn't work it out yet. The output voltage using the V out formula. I'll just put on the calculator. R2 over R1 plus R2 times Vn, which is 220, isn't it? So the output voltage is, seems awfully big, 197 volts.
It was 220.
220 was the input,
Yeah.
and the output is 197.8. Seems big, but that's what you got, I suppose. Wait, what's on the top? It's not, is it R1 or R2 on the top? R2. And did I call R2?
Yeah, the formula is right.
This is,
This one is like
R1 and R2.
they are not the resistance.
No.
Doesn't matter?
Yeah, it doesn't matter which one we call R1 and R2. I should have said in the question, this is 1 and this is 2. Yeah. The reason the answer is so different is because in the previous one we had, I think, the small resistor first and then the big resistor. Which way around was it?
Yeah, R2 was the small one.
R2 was the small one, and now in this example R2 is the big one. That's why it's so totally different. So now we get 197.8 volts. So that is 197.8 squared here. Okay. So if I just square this and divide it by 0.8991, the power is 43.5 kilowatts. Okay, part 3. What is the current? Okay, well this is all simple stuff now. What's the formula for current? V over R. Do we know the V? Yes. Do we know the R? Yes. So what was the V? What did I say?
197.8.
Great. And the R? 0.8991. So the current is 220 amps. Okay. Yeah.
Why the
I use this formula because I know the length, I give it in the question, I know this and I know this. So I didn't type it in, I know that this will be the answers.
But if we split it, it's still 1.
Yeah.
Like I equal our
No, this here, this is like for R1.
No, they are in the power.
The R in the power? Oh, here. No. In this one. Oh, I know what you mean. Is that R for both of them? No. In the question, look, I said, what is the power of the large resistor? So, if it helps Fuang, this is actually R2. It's power 2. Yeah? Yes? Okay, what's next? What is the power input? So the power input, that's IV. The input voltage is 220, but do we know the current?
220 also.
Yeah, but if you found it.
Yeah, from the period.
Oh yeah, we did actually, didn't we? 220. So if we just multiply the two of those, we get it. Yeah. So what is it? 220 times 197. No. 220 times 20. Oh yeah. 48.4 kilo. And lastly, what is the efficiency? So do you remember the formula for efficiency? output over input times 100. So what is the output power here from the large resistor?
48.4.
No, output is the 43.5 and the input is 48.4. So we just need to make that a percentage. So this is a 90% efficient potential divider. Well, it was quite hard, wasn't it? I don't know, I think it was because the lesson was so easy. I felt the need to make the homework so hard. Because there was only one formula in the lesson.
Are the questions in the exam this or?
No, they're not. For the exam, guys, just so you know, for the exam, you know, completely forget about part 6. Part 1 to 5 will be like the exam here. Yeah.
For semester 2, do we like go more in depth in like mechanics and? So
I'm
like
sure I've talked about this class before. We forget about what we've done in semester 1 and look at different topics.
So like in the
Mechanics is finished.
So like
Electricity is finished.
The semester 2 exam would be the same difficulty
Yes.
as the semester.
Yes.
Is that the machine for math?
Sorry, what
Yes.
about the assignment?
Well, some things we look at in more detail, like calculus. The assignment, what about it? What do you want to know about it?
When
Teach it. Let me transfer it to you now. What we can do, we have 2 hours tomorrow and 1 hour on Friday. We can make the 1 hour class on Friday assignment class.
How about tomorrow?
How about tomorrow?
Yes.
No.
Too much time.
We still have to finish waves. Wait, there's still 1 minute left.